All right, let's talk about explore number 2. Go ahead and get your notes going there. Write down the date and write down the essential question. How can position, velocity, and acceleration be used to describe the motion of an object? Okay, so why don't you tell me what you know and trust in yourself. You probably know a little bit more than you give yourself credit for here. What I know or think. Okay. When we're describing an object that's moving, we can talk about its position, right? What do we mean, and how can we do that? And we may talk about its velocity, and then we may talk about that object's acceleration. How can these things? How do we use these things? What exactly do these things tell us when we're using them in reference to a object? Just hit pause and write what you think. Okay, well, hopefully you did that. So let's take a look here. In black, we see over on the left, how is the displacement of an object determined? Okay, so we're taking a look here. How is the displacement? So maybe I can say how is displacement determined? Right? We're not talking necessarily about the amount of engine displacement or something. Maybe, but you can see I've got it highlighted in green here. The displacement of an object is defined as the vector between an object's starting point and ending point. The starting point is called the initial position, and the ending point is called the final position. Okay, so let's write that down too. Okay, defined as um, defined as the vector between an object's starting point and ending point. So examples, I guess. Example. If I were to say that point A is my starting point, right? Maybe this is my my home, maybe, right? And I say that I went to a point B was where I finished. Okay, then my displacement would be from A to B. That's the displacement. Okay. What if I have this kind of example? What if I do this? I have my point A is where I start. Point B, maybe I go to the grocery store. Point C, maybe I go to school, and maybe I ask my mom and dad if I can spend the night at my friend's house. And so my end for the day is point D. Well, in this case, where is your displacement? Your displacement is from A to D. That's your displacement, right? This is where we start, and this is where we finish. Okay, so B and C don't matter when we're talking about displacement. All right, this is your displacement. That's it's the distance from start to finish. Okay, the other points don't matter with displacement. Okay. Now, if we're talking distance, then all those points do matter, right? We would want to know the distance between A and B and C and C and D. Okay, so but that's displacement. Okay, and if we take a look over here on the left hand side, they use a number line. Okay. Okay, so if we use number lines as an example, maybe if I say that this is my number line, and maybe I have 0 in the middle, and I have -1, -2, -3, -4, -5, and I have a +1, +2, +3, +4, and I have a +5 over here. If I start at, let's just say at point 1, okay, this is where I start, okay, and I go to the left, 1, 2, 3, 4, 5 steps, and then I go back to the right, 1, 2, let's just say that. What is my displacement? My displacement would be if this is my finish point, this is where I end, and this is where I start. So what's the distance between those 2 points? It's 1, 2, 3. So my displacement in this case would be equals 3 in this case, right? Just the distance from start to finish. All right, enough of that. Okay. Oh, well, if I were to say how far I did on my distance versus, let's just say this versus distance. So how many steps were involved for my total travel? Well, then I'd have to count all the steps. The red going left, 1, 2, 3, 4, 5, and then 2 to the right, 6 and 7. So distance would be the 5 plus the 2, and that's going to give us 7. So my distance would be 7. My displacement would be 3. Okay, so make sure you keep those clear. Okay. So they use a formula. It can be expressed. Let's just put it this way. B displacement can be expressed as a change in x, delta x, is equal to your x final, your final position traveled, minus your initial distance traveled, minus your initial distance traveled. Okay. Basically, just subtract the distance out between the 2 points. Okay, what is the, okay, so we talk about that. So in this problem here, you can see this is kind of exactly the same thing we've been talking about. Distance accounts for the whole path taken. Displacement is just the difference between the start and the finish, right? This is start, and this is finish. So displacement is just that distance, right? It's from here to here. That's your displacement right there. Okay. All right. What is the difference between displacement and distance? Well, we just explained that, right? And it's worth paying attention to the details in the text. Note that unlike the displacement, the distance traveled ignores the direction of motion. Moving from the 8 mark to the 2 mark on the number line is just considered moving 6 meters. The fact that the ant was moving in the negative direction is irrelevant. So they're referring to this whole thing with this ant moving on the number line. Okay. They're just trying to get you to conceptualize distance and displacement. Distance traveled is a scalar quantity since the direction of each individual motion is not considered in the summation. Right? With displacement, it is considered, right? If you go to the right 5 and then you go back to the left 5, you're back at 0, right? But distance would say you had traveled 10, all right? So more on that. Okay, what is the difference between speed and velocity? Okay, so let's see here. Let's go ahead and write that down. I think this is going to be, what is this going to be? Roman numeral 2, okay? What is the difference between speed and velocity? You remember speed, we just talked about that. Speed is your distance divided by time, right? Your velocity is very similar to speed, except that it has direction. Okay, velocity is displacement over time, and speed is distance over time. Okay. That might be an interesting little nuance there, okay? So let's go ahead and write this down, A, okay? Velocity, what you normally think of as how fast you go, right, is displacement over time, okay, versus speed, which they in physics want to make the distinction that it is the distance over time. Okay. All right. To specify the velocity of an object, one needs to state both how fast it is going, its speed, and the direction in which it is moving. So here maybe we can make a little note to ourselves. With velocity, we specify speed and direction. Okay. It is a vector quantity. Okay. And what I'm doing right now is we're just kind of reading through this to specify the velocity. We need to talk about how fast it's going and the direction. This velocity requires direction. Therefore, it is a vector quantity. Okay. For the velocity of an object to change, either the speed or the direction will have to change. Okay. So that might be also worth noting there. Where do we want to write that here? For velocity to change, then you're going to either have a change in the speed, or you're going to have a change in the direction. All right. This is for the velocity of an object to change. So for velocity to change, either speed or direction changes. Okay. Okay, so we saw this equation already. Speed is determined by dividing the distance traveled by the time it took. This makes sense, since speed and distance traveled are scalars. However, velocity is a vector, so instead of using the distance traveled to determine the average velocity, displacement in one dimension is used. The equation for the average velocity is, all right, so let's go and put this down as letter B. Well, if we said that speed was distance over time, and we're saying the velocity is displacement over time, then we would have to say that the best way to represent that is to say that, and I'm looking right here, just trying to track this stuff with your notes so you guys can follow here. Okay, so instead of saying distance over time, we're saying the change in velocity, the change in your position. Okay, remember the change in position, that was going to be over a change in time. And that is simply saying that your final position, which is a vector, right? These are vector quantities, so they're using arrows to just signify that, minus your initial position, that's what delta x is, right? Divided by your change in time. So that would be your time final, subtract your time initial, and that's what delta t is, okay? So, and again, don't forget the delta, these little triangles, delta, that means that's what we call the triangle, delta, and that means a change in dot, dot, dot. A change in position, delta x, a change in time, delta t. All right? Okay. So the velocity of an object at any particular moment during this time interval is known as instantaneous velocity. And it may be different from the average velocity. Okay. So instantaneous velocity, let's put this down as letter B. Okay. Is at a specific time interval. The velocity at a specific time interval at a specific time. Okay. All right. Make sure to click on those, okay, and get comfortable with those definitions, okay? Okay. The rest of this stuff here, I'm not going to be too worried or concerned about right now, okay? You have some sample problems. This stuff in here that I said I wasn't going to be too concerned about, too worried about, it just kind of goes and takes this general idea here, letter B, instantaneous velocity, and it talks about whittling that velocity down to that specific time interval. As time approaches zero, where the change is the smallest amount of change, that's going to be your instantaneous time. Okay, so they just kind of go into detail and read on that. But if you have the mind to read that, certainly go ahead and do that. Okay, and the videos are probably going to be very helpful in doing that as well. Okay, alrighty, so let's do this. That's going to take care of it for your notes today. And let's go ahead and do this. Let's go ahead and just write ourselves a summary. Okay. And that does it for us. All right. You guys have a great rest of your day and evening.